Hello, class, and welcome to laboratory activity 4.3, where we're dealing with solubility. And in this lesson, we're particularly dealing with concentration. Okay, and so our major understanding for today is that the concentration of a solution may be expressed as molarity, percent by volume, percent by mass, or parts per million. And we're going to focus today specifically on molarity and parts per million. Okay, and so for today's lesson, it's important that we refer to the New York State Chemistry Reference Table, specifically Table T, concentration. We'll also be looking at the periodic table at one moment during this lesson, so it might be helpful to have that out as well. Okay, and so for this lesson, we're basically just going to compare two different solutions of different concentrations. And so the first one is 0.002 grams or 2 milligrams of sodium chloride in 0.50 liters of water, okay, where NaCl is our solute and water is our solvent, okay? And so this would be what we call a dilute solution. And so when quantifying dilute solutions, okay, so quantifying dilute solutions. Okay. We are going to use parts per million. Parts per million. Okay. And it says units of ppm. Okay. And so the equation for calculating parts per million is simply parts per million equals mass of solute, and this would be mass in grams, over mass of solution. And then this whole thing multiplied by a million, or 10 to the 6. Okay, that's why it's called parts per million. Okay, so now a couple quick conversion items here that we need to talk about before we can start determining our concentration of this beaker in parts per million is that 1 liter equals 1,000 milliliters. Okay, so there's 1,000 milliliters in 1 liter. Okay, and for water, so solutions generally, if we're dealing with really dilute solutions of where a solvent is water, we can just assume the density of water here. And so the density of water is 1 gram per 1 milliliter. So a dilute solution where the solvent is water will be approximately 1 liter of that solution would be approximately 1,000 grams. Okay. Now this only works if our solvent is water and if our solution is very, very, very dilute. So for instance, 2 milligrams of salt is not really adding into the overall mass of this solution. So we can kind of ignore it. Okay, and so now let's look at our example problem and let's apply this equation. Okay. Okay, so we have our solution. We want to determine parts per million for our solution. And we know that we have 0.2 or 0.002 grams of NaCl. Okay, so that's our mass of our solute. Okay, and then since we know that 1 liter has 1,000 milliliters, then we can assume that 0.5 liters would have 500 milliliters, and each milliliter is worth 1 gram. So the mass of our solution would basically be our 500 grams of water plus the 0.0002 grams of salt, but that's so small we can kind of ignore it and leave it out, okay? But if we want, we can add it here. 0.002 grams of our salt. And again, that number, this value here is so small that it's not going to really do anything to our calculations. And then we're going to multiply it by 1,000,000. Okay? And when we do this, we'll find that this solution has a concentration of 4 parts per million. Okay, so this is a very convenient way of quantifying very dilute solutions, because even though there's only a tiny mass of solute in this beaker, we're able to use a whole number of integers to represent its concentration by using this method of parts per million. Okay, so now if we're looking at more concentrated solutions, then we'll use a different method. Okay, and so for this beaker over here, we actually have 20. So this is 20 grams of NaCl in 0.5 liters of H2O. And so for quantifying concentrated solutions, we are going to use molarity. Which is represented by a capital M. Okay, and so the equation for molarity is molarity equals moles of solute over liters of solution. And I'm going to abbreviate solution because I'm running out of space here. Okay, but again, this equation is on our New York State chemistry reference table. Okay, now one quick aside for our molarity equation is that we need to sometimes convert mass into moles for this calculation. So we have to remember our mole calculation equation from earlier in the year. And so number of moles equals given mass over our gram formula mass. Okay, and so we might need to take this, use this equation to convert a mass to moles, and then we can apply our molarity equation. Okay, so now let's again look at this example. So first thing we're going to have to do here is we're going to have to convert grams to moles. Okay, and so we can use our mole calculation equation. So number of moles will equal our given mass, which is 20 grams. Okay, by the gram formula mass, which is the atomic masses of each atom present in the compound. So since we have one sodium, and sodium has a mass of approximately 23 grams, okay, and we have one chlorine, which has a mass of approximately 35 grams, we end up with a gram formula mass of about 58 grams. So our calculation here is going to be 20 divided by 58, and we're going to end up with a number of moles equal to 0.34 moles. Okay, so now we can apply this value to our molarity equation right here. Okay, and so we can say that our molarity, capital M, equals 0.34 0.34 moles over 0.50 liters. Okay? And when we solve, we'll find that the molarity of this solution is 0.68 molar. Okay? And so, as you can see, even though that this solution is far more concentrated, we found a way of quantifying its concentration in a reasonable number using molarity. And for very dilute solutions, we can use parts per million to quantify how dilute a solution is. And so we don't have to consider these small numbers. We can use whole number integers or very realistic values for determining concentration. Okay, so this is our lesson on concentration, and I'll see you for the next lesson. Bye.